Should be waiting for now until realize you can't read it. You should have been realizing that 2 minutes ago when I put it up. Start checking these answers. There's one on the bottom right corner. Check it. Let me know when I can flip it. Keep checking. Let me know when you guys are done with this one. Calculator. I want to know increasing, decreasing, concave up, concave down, all those intervals. And then I want to know any local extreme values, and I want to know inflection points. And I want you guys to create a sign chart that states all of that information. Create that in your group. Again, I would solve for all of the critical points and inflection points first.
There's a picture of the graph in question. A picture of negative 2x cubed plus 6x squared minus 3.
Mins or maxes. That is the only possible places you can have a min or a max, besides an endpoint. Only at an endpoint or at a critical point can you have a min or a max. So these are good to get. So how did you get these? We took the derivative, and then what did we do with the derivative? Yes. Now what else does the derivative tell me? Sign it. Besides where the critical points are. That's what you were saying, and I hold you up on that. What? I can't hear you. The other thing the derivative tells you, Marco and Sonia said, is where the function is increasing and decreasing. And how do you tell that? Amina, where a function is increasing and decreasing if you're looking at the derivative? How can you look at it to tell you that?
The derivative is positive, it's increasing.
Oh yeah, okay. So when the derivative is positive, the original function is increasing. When the derivative is negative, the original function is decreasing. So those are two valuable things that you can get from a derivative. What are those two valuable things, Jessica?
To find out when it's increasing or decreasing.
By the intervals, the original function is increasing and decreasing, and what do the critical points tell us?
When it equals 0.
Yes, that's how we solve for the critical points. And then what do those tell us? Exactly. Okay. So let's first solve for our critical points. I took my derivative, and what do I do with it? Set it equal to 0. Now, instead of Jedi mind tricking this, let's see if we can factor it. Does this thing have anything in common?
Yes.
What? A 6 and? X. Yeah. And I'm going to factor out a negative 6. Why? Why not? If I factor out a negative 6, what's this thing equal to? X? Yeah. And either way, you'll get the same thing. So now I have two things equal to 0, which means the first thing has to equal, and they're multiplied together. Which means the first thing has to equal 0, or the second thing equals 0. So I set them both equal to 0. And I get x equals 0 or x equals? What did I just solve for, this x equals 0 or x equals 2? Joanna. And what does a critical point tell me? Okay, cool. Alright. So in order to determine that stuff, if it is a min or a max, yes, I would indeed have to look at where it's increasing and decreasing. But before I do that, let's take the second derivative. And what does the second derivative tell me? Inflection points. How do I solve for an inflection point? Estella. How do I solve for an inflection point? Take the second derivative and set it equal to 0. Eric, how do I solve for inflection points?
You take the second derivative and you set it equal to 0.
Okay, what else am I going to look at when I'm looking at the second derivative? David. I'm looking at what, okay, so we just found inflection points off of the second derivative. That's when that equals 0. Yeah, the second derivative also tells me when the original function is concave up and concave down. When the second derivative is positive, the original function is, Lauren, concave up. When the second derivative is negative, the original function is, Jesse? When the second derivative is negative, the original function is concave down. Good. Okay, so let's solve for the second derivative. What's that equal to? Johnny? Okay, first thing I'm going to do is set this equal to 0. Why am I setting this equal to 0, Johnny? Great, possible inflection point. So what do I get for x here?
1.
Great. Alright, so I have all my critical points, and I have all my inflection points. So I'm going to list them all out left to right. Okay, Anna? Alright, here we go. X is 0, 1, and 2. I'm going to make a nice little chart with everything all listed out. Okay? So I know that the first derivative equals 0 at 0 and 2. So now if I wanted to know the intervals when the function is increasing and decreasing, I just need to check the sign between the zeros. So let's check to the left over here. What's the number to the left of 0? Wait a minute. -1. If I plug that into here, do I get a negative or positive?
Positive.
I get a positive. What about here?
Negative.
Negative. What's a positive times a negative?
Negative.
So that everything in this interval is negative. I check a number between 0 and 2, like Sonia. I plug in 1 into the first thing. What do I get? Positive or negative?
Negative.
What about the second one?
Negative.
What's a negative times a negative?
Positive.
So that means everything between the zeros is going to be a positive first derivative. I check a number to the right of 2. Roxana, what's the number over here? 3. What do I get when I plug it into here? Positive or negative?
Negative.
Negative. This one? Sorry.
Negative.
3.
Positive.
Yep. What's a negative times a positive? What's that?
Negative 10.
Oh, in general, I wasn't in the way.
No, I don't know.
Oh, that's something in my better door than a window thing. I see. So it didn't help. So negative times a positive is?
Negative.
Okay, great. So now I have all the information I need to know in order to determine the, yes?
Well, like once you find like before 0,
Yeah.
you know, like that's negative, can't you just fill it out without having to like does it work that way? Or are there cases where it's not? Because the sign just changes after each 0.
Hold on. Little problem over here. No, not all the time. But I'm thinking of who had Math 4 people? Who were here for Math 4? If the multiplicity is even, that means it's not going to change sign at the 0. It's going to kiss it. Like I was going to multiply it out, but I'll just write it here. So x minus 1 squared is this function right here. Say this was the first derivative instead of negative 6x squared plus 12x. Well, check this out. If this is the derivative function, the derivative is positive 0 then positive. You know what I'm saying? Which means it's neither a min nor a max. Does that make sense? So usually yes, but not always. So just be careful. You know? Yeah.
Wait, isn't the derivative negative 0?
I'm saying if this was a graph, of the derivative.
Yeah. Oh, okay.
Do you know what I'm saying? So like this thing. So let's see. I'm just going to multiply it out. So this is my. So here's, let's see, x squared minus 2x plus 1. So original function could be x cubed over 3 minus x squared plus x, I don't know, plus 2 or something. At 1, the derivative equals 0, but it's not going to be a min or a max. If you guys want to write, if we have time to solve this at the end. But so just be careful.